Hello students, in this video lecture we're gonna talk about related rates. So in these problems we try to find the rate at which some quantity is changing by relating it to the other quantities whose rates of change are known. And first example that we're gonna start with is going to be the following. Assume that oil spilled from a tanker spreads in a circular pattern whose radius increases at a constant rate of 3 feet per second. How fast the area of the spill is increasing when the radius of the spill is 50 feet? So first of all, let's try to think what's going on. We have a tanker. And the oil is spilled from the tanker and it spreads out in approximately circular manner. So the oil is going out in the following way. Alright, so first of all, what kind of variables do we have over here? Our variables are the following. T is equal to the time in seconds from the moment of the spill What else do we have? We have the radius of the spill, after t seconds that passed from the moment of the spill. And we have the area of the spill. Now let's talk about it a little bit about rate of change. Rate of change, we didn't talk much about it, but just a little bit in the beginning of the semester. But rate of change just means derivative. So how fast the quantity is changing with respect to some other quantity, like so basically if we want the rate of change of the radius, the rate of change of area with respect to time. This would be derivative of A with respect to time. So this is how fast the area is changing when time goes by. For this particular problem, we would like also to introduce new notation. So new notation, which is dA dt, which is derivative of A with respect to time. And we would like to know what is the rate of change of area with respect to time when radius is equal to 50 feet. And that's our main question in this problem. But what does it really mean? It means find the derivative of A with respect to time and evaluate it at r equals to 50 feet. That's what it means. So what is given in this problem? In this problem we're given the rate of change of the radius. So rate of change of the radius is dr dt, which is how fast is the radius changing. And the rate of change of the radius, we were told, is 2 feet per second. 2 feet per second. Alright, so what do we want to relate? We want to relate the area to the radius. So if we have a circle, we know that area of a circle is A equals pi r squared. Right? This way we can find the area of a circle. So in this particular problem, A is not really fixed. If we write A equals to pi r squared, A is a function of time. Which does it mean? It means it changes with time. And radius is also a function of time. So what we're going to do, we're going to take derivative on both sides. With respect to time. So let's try to do this. On the left side we're gonna get derivative of A with respect to time, and on the right side we're gonna get derivative of pi r squared with respect to time. So on the left side we just can't really do much, so it's just derivative of A with respect to time. But on the right side we can calculate the quantity. So pi is a constant, so we can move it outside of the derivative. Now we have to find the derivative of r, but remember, r is not just r, but r is a function of time. So we have function raised to the power 2. Therefore we need to use the chain rule. The chain rule says take 2, put it down, multiply by the function, and then multiply by the derivative of the function. But for the derivative of the function, since we don't really want to use prime notation, and I'll make few comments on this later, the derivative we're going to write as d dt of r. So let's try to see what we know and what we need to find. We need to find the derivative of the area with respect to time, and we know dr dt, that's equal to 2 feet per second. Alright, so let's try to use the new notation. New notation is derivative of A with respect to time evaluated when r is equal to 50. So we get pi times 2 times 50 times dr dt, which is also equal to, I said 2, but I think it should be 3. Should be 3, and let's go back and check. 3 feet per second. Sorry, made a mistake, so I'll fix it. 3 feet per second. Alright, so times 3. So our final answer is 3 times 2 is 6, times 50 is 300. So our answer is 300 pi feet squared per second. Why feet squared? Because the rate of change of radius is in feet per second and the radius is in feet. So feet times feet per second. So we're gonna get feet squared per second. Alright, so this is this and this is that. Alright, so this concludes this little lecture. In the next lecture we're gonna write the procedure down and we'll do a few more exercises. So I'll see you next time.